Continuing our look into the law of cosines, we're going to investigate case 3, where we have two sides and the included angle. Our objective, use the law of cosines to solve an oblique triangle when given two sides and the included angle, abbreviated SAS or side angle side. All right, as usual, if we know some things that are going to be applicable, let's go over them. Well, we now know the law of cosines. A squared equals b squared plus c squared minus 2a2 times b times c times the cosine of a. And you can switch these literals to have b squared to solve for b squared equals and to solve for c squared equals. We also know the law of sines, which is going to become applicable in this first example that we may want to use it again. It's the simpler of the two to use. We know what solving a triangle means. Find the other three parts of a triangle when given three parts, at least one of which is a side. We know that the sum of the three angles in every triangle is 180 degrees. And we know that when it's a triangle, the side lengths and the opposite angles of triangles are directly related. The largest angle of a triangle must be opposite the longest side. The smallest angle of a triangle must be opposite the shortest side. So let's put into play. I'll leave this here so we can see the law of cosines above. Let's solve a triangle using the law of cosines. Solve the triangle with side A equal to 45 units, side B equal to 67 units, and angle C equal to 35 degrees. Okay, as usual, I'll draw just a simple triangle. It will not be to scale, but I'm just going to use it to give myself something to write on and to make sure that things are matching up. There's ABC. Angle C is 35 degrees. Side A is 45. Side B is 67. And here's side C. So again, the reason we can't use the law of sines in this is you'll notice we don't have a ratio pair. The law of sines requires that one of these pairs is a known ratio in order to use proportional reasoning to solve it. Here we have angle C, we don't have side C. We have side A, we don't have angle A. We have side B, we don't have angle B. So we don't have anything that we can set up into a proportion to solve. So we're going to use the law of sines, we're going to use the law of cosines to solve this one. And first, if we look up here, we have side C. Well, we can use this version of the formula to find side C. So let's see, I'm going to put on here, find side C first. Okay, well, let's see here. Here's our formula. C squared equals the sum of the sum of the squares of the other two sides minus the product of those two sides times the cosine of the angle between them. I'm going to go ahead and take the square root of both sides. Of course, we use the positive square root because we're dealing with a triangle, so we're not concerned about the fact that there's a negative square root. So C is equal to the square root of the right side here, the square root of a squared plus b squared minus 2ab cosine of C. And we have all three of these pieces, so let's go ahead and put it in there. C is equal to the square root. Well, A is 45, so 45 squared, plus B is 67, so 67 squared, minus 2 times A, 45 times B, 67. Looks like I got to extend my square root symbol here, times the cosine of 35 degrees. And thankfully we have calculators. That goes into a big old calculator. And side C is 39.68. Okay. I know that these two are whole numbers. I'm going to leave it as 0.68 just because I'm going to use this number elsewhere, so the math is not done. I'll note over here that side C is 39.68. Of course, that rounds to 40, and we could go there perhaps, depending upon how much specificity, how much accuracy the problem asks for. But that's side C. Now we check our triangle, and we know that we're not being helped here. We know that 35 degrees has a side length of 39.6, but that's not telling us anything about whether or not this is actually a triangle. Okay, given that we've now solved for side C, we now have a ratio pair. We have angle C and we have side C. And as I said, most people find it easier to use the law of sines. Slide down a little bit here, make sure I'm still straight on the paper. So I would suggest here now, you can use the law of cosines. You can use the law of cosines again. Okay, you can do the same thing. It's a little tougher to find the angle. We'll see that in another example. To find angle A or B, but most people use the law of sines. Most people find the law of sines a little bit easier, okay, because it's simply a proportion to find A or B, angle A or angle B. Okay, it's usually easier for most people, so I'm going to use the law of sines here. Okay, make sure again I'm straight. So we have a ratio pair. So here's our known. We know C over cosine of C. That's our known ratio. Let's find A. So I'll put side A over, not cosine. Look at me, using the law of sines, putting in cosine. I bet that was confusing. You're probably thinking, what's he doing? How about I put a sine here? Use the law of sines? Let's use sines, Coleman, over the sine of angle A. So again, we have a known pair. We have three of the four parts here. A known ratio, and one of these two, in this case, we know the side length. So let's put C in here. 39.68 is the length of C. Angle C is 35 degrees. Side A we know. We're looking for the sine of A, which is our unknown. Okay, that's our proportion. Cross multiply. This comes out to be the sine of A is equal to 4 decimal places. I came out to 6505. 0.6505. Inverse sine both sides, and angle A turns out to be 40.58 degrees. And again, I've just gone to 2 decimal places while I'm doing my math. Come up here, let's put 40.58 in here. And let's check ourselves a little bit. Well, let's see. This angle is larger than this angle. So the side opposite this angle should be larger than the side opposite this angle, and indeed it is. So we have a triangle, we're still good. And now, well, we know 2 angles. There's no reason to use law of sines or law of cosines, because we know that the sum of any 3 angles in a triangle is 180 degrees. So we found A, so we know that B is simply going to be 180 degrees minus angle C, 35 degrees, minus A, which I have as 40.58. And angle B, using this property that we've known forever, is 104.42 degrees to the nearest hundredth. And again, we can now round. We're now done. We can do some rounding as necessary. Let's go into our drawing, and let's put in 104.4 up here for 2. And let's check our triangle. Okay, this is the largest angle. This is the longest side. That's a good thing. This is the smallest angle. This is the shortest side. So we feel pretty good about our triangle. All right, let's do a real life example, an application problem. Give me a moment to switch up my papers. Okay, here we are. All right, make sure I'm in the right place, kind of, sort of. Okay, 2 people are talking to each other on their cell phones, The angle between their signals at the tower is 132 degrees. So here's the 132 degrees, if you can see it. As shown below, how far apart are they? A little hard to see. This is 3.7 miles here from this person on the right to the tower. This one is 2.4 miles here from the person on the left to the tower, and the angle between them is 132 degrees. Well, let's make a triangle. Okay, I get that. Looks like it's a little bit, oh, okay, it doesn't matter. There's my triangle. Okay, let's label the triangle. Okay, well, I'll label this angle A. I'll label this angle B. I'll label this angle C, which means that this is A because it's opposite angle A, which means that this is little c, it's opposite angle C, and it means that this is B, which is what we're looking for. We don't know B. Okay, that's what we're looking for. How far apart are they? We're looking for the distance from here to here, which is indicated as a small b in the way that I have labeled the figure. Okay, you'll notice again, we don't have an angle pair. We don't have a ratio pair. I have angle B, I don't have side B. I have side A, I don't have angle A. I have side C, I don't have angle C. So the law of sines is not going to do anything for us. Need to find B, so why not use this version of the law of cosines? A squared plus c squared minus 2ac times the cosine of b, because I have all three parts of this. I can find b. I know side A, I know side C, and I know angle B. Well, as before, I'm going to go ahead and take the square root of both sides before I substitute. A lot less writing, actually. Take the positive square root because we're dealing with real life in a triangle, so there's no such thing as negative lengths. Okay, so now I'm set. Let's substitute. So b is equal to the square root, and I know it's going to be longer than that. So let's see, a is 3.7 miles, square that. C is 2.4 miles, square that, minus 2 times A, 3.7 times C, 2.4 times the cosine of B, which is 135 degrees. Okay, again, I'm not doing this thing by hand. I actually have no idea how to do that by hand. I'm putting that in the calculator, and chicka with the calculator, and out comes B, 5.6 miles, approximately to the nearest tenth. Let's put 5.6 up here and see if we can check our triangle. Okay, well, obviously in our triangle, this angle of 132 is obtuse, which forces these two angles to be acute. So this is by far the largest angle at 132. So B should be the longest side because it's opposite that large angle, and 5.6 miles is longer than 3.7 and 2.4. So we've checked to make sure our triangle is indeed a triangle, and then it makes sense. So there you have it, law of cosines for those cases, side, angle, side. We're now going to, in the next video lecture, we'll take a look at the law of cosines with 3 sides.